So if we then start getting into what data am I using day to day, and this is a page on a computer that I've just been literally looking at 5 minutes ago. I would probably look at this screen 10 or 12 times a day for each farm every day. It's a summary screen telling me what's going on in that house, and I want to know the average temperature, but I want to know what should it be. And I want to know floor temperatures because of the underfloor heating. Humidities are really important, air pressures, water and feed intake, mortality. And then we get down to the production side, and I want to know the weight, and I want to know how much they're growing by, and I want to know what the target is. So, one of these sheds, this one on the end, 1,465 grams. They've grown over 70 grams that day, and the target's 1,355. So I can feed that through to my customer, and I'm running about a day and a bit in front. And then I can also do my own calculations. So when a bird is about 7 days old, at that point, give or take a few £1,000, I can work out what my check will be at day 39. Because we've got so much data that we know within a single gram at day 7 what we're going to be at the end. And we know every 1 gram at day 7 gives me 8.8 grams at the end. So if I can get 1 gram heavier than it was last time at day 7, that's going to be best part of 9 grams heavier at the other end for me. So we collate all of this data all the time. And I guess one of the things is, as well with the data, you don't have to use all your data there and then. It's important that you extrapolate the bits that you do want to use and perhaps save the rest, because in years to come, someone's going to say, well, how was that compared to previously? And we've had some speakers this morning saying they can't actually say how much improvement some of the technology's given them because they're getting data that they didn't have previously. So it's important that we do archive all the data, whether or not we use it all. We then do take that data through a separate program and then start to break it down into some more technical stuff. And from this page, if the spreadsheet was extended, this is where we actually do daily EPFs and daily food conversions and daily margins. And this program will take all the data from the other programs and bung it all together for me and start to tell me what's going on. And it's not something that I refer to 12 times a day every day. But it is something that's there, and it is something that's really, really good for starting to benchmark individual sheds or individual hatcheries that supply me with their chicks, or I could look at the different ages of the parents that laid the eggs that formed the chick. I could look at different times a year. Really good for just benchmarking within our own company. But it does it all automatically. I don't have to do anything. I don't have to check it's there. I just know it's there, and I can go and look at it whenever I want to. A graph that I would tend to look at a lot, and I prefer graphs as a farmer, to be fair. It's a bit more instant and visual. Numbers can be a little bit confusing sometimes. But this is a graph showing food and water. Now, we can graph the food because we weigh every 10 kilos into the shed. So every time the sort of lower lines that you're seeing there have a little step in them, that means the feeders have run and I know they've fed. What's really great about that is you can set a very simple alarm on that computer to say, if they don't feed 100 kilos every 2 hours as a minimum, please ring me. Because the farmers in the room will know an auger does not break down at 9 AM on a Tuesday morning just as you walk into that shed and find it. It breaks down at 3 AM on a Saturday or Sunday night when you've got no blinking spares and your fitter's on holiday. So it's really important that we alarm these things and it gets us out of bed and we go and fix it. And then the top line is showing the water. And where you're getting the flat lines, that's where these birds are having sleep periods. Because under assured schemes, we need to make sure they do get a sleep period, so you'll get a flat line, no eating, no drinking. But that graph is a bit like my summary table. I will look at that 10, 12 times a day. And I will start to see, we had it 4 days ago when this hot weather first came. Chickens get used to hot weather. If you set a batch of chicks in Saudi Arabia in 40 degrees in the desert, they will grow because they're used to the heat. If you set those chicks in this country in 10 degrees when the chicks arrive, and okay, you warm the shed up, but generally you're pulling cold air in through your air vents, and you suddenly get a hot spell like this, they do not like it. And what we've seen on the graphs is you can see where the water starts to tail off during the day, where they're getting stressed and they're sitting down and they're not as active and they're not going to the drinkers as much. And then once it cools down in the evenings, you'll see the water curve start to pick back up again. But we can start to use that to look at how the birds are moving around. If we know they're not up and drinking, we also know they're not up and feeding. So then we have the potential to start to play around with ventilation and cool the birds. But then you have to be really careful not to chill them, because again, they'll go flat if they get cold. And it might be 28 degrees, but if you whip air over their backs at 6 meters a second, you will chill them. and they will go flat. Even though the ambient sensors will be telling you it's quite warm, it's that wind chill factor. Automatic bird weighing, as I've touched on, really, really important for us. We must keep our customer abreast of where we're going. But also for me, you know, you could nearly take that and have another little table underneath there and turn it into pound notes, because that's money. I sell live weight, so that's telling me how much money I'm making. But it's not just about what they're growing on that day or what they are at that moment, it's about trends as well. So this graph starts to look at some 3-day averages. Because as an individual daily growth rate, you can get a little bit too much spiking and dipping, and it's quite difficult to see what's going on. When we start to blend it into 3-day averages, you get more of a trend. And you can see on this graph, look, we're growing ahead of target, so the bold green curve line is the sort of target. The outers are the max min that we would expect for those birds. And you can see by the blue bars, around 17, 20 days, we're getting a kind of spiking growth. Then it seems to slow down, and then it spikes again. And we don't know, and we still don't know 2 years on, whether that's normal, or whether that means that the birds grew so fast that they got challenged by something else. Did they get challenged by coccidiosis? Did they get challenged by some nutrient content in the feed? Did they just overgrow themselves and decide they're going to slow down a bit? We don't really know, but we are working with the data. It's not giving me the answers of the data, but it's giving me something to look at. And we're trying to see, do we suppress the growth earlier on to maybe get better growth in the early days of the 20s? But we'll wait and see. We monitor CO2, really, really important. You know, we're venting the sheds all the time. When I came into the industry and said, why do you vent those sheds like that? Because that's what we've always done. And why have you always done it like that? Because the Dutch told us to do 1 cubic metre per kilo per hour. So that's what we do. Well, what are you trying to do? Well, I'm trying to bring oxygen in. Well, why aren't you measuring the oxygen? Well, it's expensive, it's this, it's that. Well, what about measuring the CO2? Well, you could do, but the sensor's 1,200 quid. Well, 1,200 quid on a £2 million spend is not really the end of the world, is it? So we put a CO2 sensor in, and that wasn't common practice when I put that in. And we got some pretty horrific figures. You know, we were getting CO2s in modern buildings going up to 6,000 parts per million, and we were told to keep it under 3,000. But nobody was really recording live. You would go in and sample a shed and then walk out again, but only when you see it live you get the diurnal rhythms of that CO2. And so now we are monitoring it all the time, and we can have our fans that are actually being controlled by the CO2 level in that shed. Everything's remote accessible. You know, when we first started doing it, it seemed quite novel to put this slide up and say it was remote access to the sheds. You know, we've been doing it for a number of years, but of course now everybody thinks that that's just normal. You know, why wouldn't you? And what's really interesting, that the farm that we built in Sleaford, 340,000 birds on a contract farming arrangement, we couldn't get internet in there for the first 3 crops. And those crops, if I give you the EPF figure, those crops were doing 333s, 335 EPF. The minute I got my remote monitoring, and I could actually keep an eye on those sheds multiple times a day, it did a 384 EPF. So we as a company now have a blanket rule: if we go into a farm and take it over, it has to have internet. We have to have remote access. And if I have to put my own satellite equipment in there to get that access to the internet, it's well worth doing, and I will do it. But we cannot run our business without the internet and remote access. You just don't check it enough. And you can't ring your manager and say, what does your screen say? Because he'll say, well, I'm too busy in here bedding up, or I'm sweeping this, or I'm doing something else. I'll tell you when I get there. And then when he tells you, you're in the middle of something else, so you don't have time to think about the data. So it's really important for us.